This is Galactic bringing you another science presentation on Tuesday, July 23rd, where we're enjoying a 108-degree day. The word proof has two distinct contexts in science. One, because we need the technical, rigorous proof of propositions which begin as hypotheses, because it's new, followed by the proof of the hypothesis, using the axiomatic structural approach which induces postulates. There are various terms which are somewhat overlapping in the development of science. Certain terms have morphed a little, but the overall structure of the scientific process is not complicated, and it's not really complex. When it's described antiseptically and objectively without the nuances of humanity, the human element, it's, I believe, rather mechanically straightforward. The hypothesis step, of course, is famous to everyone because it's when you go out on a limb and create a proposition that has not yet been proved. Other scientists may be acquainted with it. But the one we're, I would say, most interested in as humans is when a genuine discovery is made as if from out of the blue. In the discovery of the ring molecule, which changed molecular physics forever. It was a huge turning point. Rather a celebrated story, relatively speaking, among people who study chemistry. The progress of a scientific discovery first involves communication. It must be evaluated according to the rigorous principles of science. So science itself really, has learned how to regulate the admission of new ideas. It's not absolute, and at any one time there will be theories which may or may not be provable or proved. That's normal, and I'm merely saying all this obvious forerunner material in order to bring out the situation that I face now, which is quite specific and quite well along in the scientific process, enough that I'm now crossing a bridge, because it's perfectly reasonable for any individual human, such as myself in this situation, to say, this is wonderful. I've gotten what I wanted. I have great insight. There are a couple of problems with being satisfied with just that, though. You haven't shared it. So you don't have any feedback. A one-person feedback system is not a feedback system, except in terms of psychology. And we do have such a feedback system. But science is anti-solipsistic. I am not my own world in science. Strictly from my own point of view, which I believe is, I'll just say, correct, without meaning to impose that on any other human. My recognition of science entails a recognition for me that it is a communication process, essentially, that without communication you cannot call it science. Any man can say anything he wants to himself. But it would be a mistake, according to what I know about science, to be satisfied, just self-satisfied, that, oh boy, I finally got the answer. It would be as if when Archimedes achieved his insight into the volume, it's a volume calculation that was highly coveted, but nobody had achieved it, and he finally realized that he got it, and he knew that he got it. He saw it all in his head. But apparently he was at the baths at the time. And the bath had a good deal to do in the story, which may be apocryphal, about how Archimedes arrived at his breakthrough insight. Now, according to the story, when he achieved this insight and he realized, he saw the equation which would solve the problem, which is of inestimable value, and it turned out to be a major insight for all of science. But this was the turning point, because at that moment, he was the only man who knew the answer. Now, in science, according to my approach to science, it is necessary now, if one has such an insight as Archimedes obtained, you must attempt to share it. You want someone else to see it, so that they can follow the same proof sequence that you followed, and then they can nod at you and say, "I'll tell the others." Either explicitly, but that's the implicitly. So there is an appeal to a higher judge. You have to submit yourself to a review board, which is essentially what we call our peers. And that produces a dilemma for some men who may not have any way to be heard. And in that case, I think we're all aware that there is some confusion, or at least potential confusion, because of another class of men who wish to fake. They want to fake having made an incredible insight. They want to be heard, because then people will be tempted to pay them to read the book or to listen to a lecture. Money, 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 by lying. And it's not the liars that are the real threat. It's the ones who are self-deceived. And that is remarkably easy to do. History proves that. Although it is on a statistical basis, so it's very hard to say that men are like this or men are like that. What we have is a situation where men can be a lot of different things, and men are actors. They're born deceivers. Now, we don't ever want, a normal man does not want to think of himself that way and would avoid that. Not every man has that ethical basis. Not every man was raised in such a way as to obtain a clear moral compass on his behavior. And in the effort to survive, there is a lot of incentive to go to maximum length. Because if you're going to die, you might be willing to steal. I personally don't believe it's possible for a rational man to judge another man who's trying to make money. For instance, in examining someone's supposed solution to the Poincaré conjecture, certainly in contests where there's a money prize. And I've told several stories about this over the past few months. But what I'm attempting to portray now is my situation in this process, where I now have a golden opportunity, if I'm willing and capable of undertaking a very special procedure, to find an actual problem in physics that requires progress. It could be directly perceived that there should be a solution where there's not, or it most often is something more subtle, where nobody is sure what the right approach is, but it must be there because the current approach is simply inadequate. So there's an element of mystery. Now, in all of this, what one is trying to do is to match a new vision, which must be rigorously proved. So it's not a fanciful vision. It's a structure. It's a new structure that has never been seen before. That's fairly definitive, and I hope sufficiently so that you see what I'm saying. But here is a subtlety that I think is not often brought out simply because for whatever reason. But there's another kind of proof, which is an extreme attention grabber. And I'll give you an example from Albert Einstein's work, where he had proposed his general theory of relativity, and it looked promising, but it was very difficult to accept without some kind of direct linkage to physical reality. It was right after World War I believe so. And I believe it was Eddington who made the measurement, but I could be wrong. You could look that up. And once he made that measurement, instant international hit. Einstein breaks the secret of the universe. And he became a hero. Certainly in the United States he did. He was a hero everywhere. And we remember him to this day very largely because of this proof. Now in my case, and we're going to wrap this up with this is the whole point. I now have an opportunity to directly grab the attention of the scientific community if I can solve a perceived unsolved problem in mathematics. That is physical mathematics that describes phenomena that we can measure. There is a very famous constant called the fine structure constant. The fine structure constant we're going to cover in the next presentation and probably for several presentations as we investigate this amazing fundamental constant of the universe. Now even that is debated, but it's generally conceded, and I am one of those that does concede this, from what I do know about the fine structure constant. It is a dimensionless constant, and it has to do with electromagnetism and with light and with the atom. And the fine structure constant must be described in this roundabout way because it shows up in so many circumstances. And I will be showing you, beginning in the next presentation, a relatively unknown aspect of this fundamental dimensionless constant. Dimensionless means that it's a relationship that is open to interpretation. E equals mc squared has units of light. The conversion factor between energy and mass is essentially light speed. It's light speed squared. That is a coefficient of mass in order to equate it with energy. E equals mc squared. I've covered that in a recent presentation for this reason that I was leading up to this. The fine structure constant has no units. It's not in it. There is no conversion. So what is it? It's a number that recurs in different situations. It was first detected, observed in the Fraunhofer lines. These are the lines that appear in the continuous spectrum by which we gain a fingerprint of light. Actually, it's chemical composition, which is amazing to say that. But there's also a correlation. These lines actually represent surfaces that are not linear. They're actually spheric surfaces because light propagates spherically. So these lines, even though they're pulled out and it looks like there's a strict linear sequence, it actually is linear. We do know that. But the lines themselves are physical. They're not hatch marks like we make, which are essentially artificial places on the line. These are not artificial. They're physical things. And these lines, it was discovered fairly quickly after spectroscopy had developed and we had further technology to further refine our insight into these most interesting lines. That they split. There's a very fine split, and scientists would very, very much like to explain that split. It's like the rings of Saturn. When we finally got close enough, it was estimated there might be as many as 7 rings or more. When we got close enough, we found out it's more fine-grained than that. There are actually hundreds of rings. And the reason for the gaps between these rings is, of course, of great interest. Tremendous interest, because it gives us insight into the structure of the universe. In this case, the structure basically of a gravitational phenomenon that has another component, which is a ring around a planet, is rather a fascinating subject. So this is similar, that you might think of this band of light that has all the little lines in it, showing its chemical composition, that when you drill down and expand it, you magnify it, you can see that the lines are split. And that's called the fine structure of the bands. And the fine structure constant describes the gap between the bands, but that is not the only place that this number occurs. What Feynman pointed out very cogently, and he's right, it stood the test of time, that this number is one of the most precise numbers that's ever been computed, developed, so that we have many, many digits of accuracy, well beyond the norm for subatomic measurements. This one is quite precise, which makes it all the more remarkable that it turns up in other situations. For instance, in magnetism. What I'll be covering in the next presentation, which I guarantee you will not want to miss, although I'll be covering it further and further over the next series of presentations beginning probably tomorrow. It could be today, but if not, it'll be tomorrow. I'm producing about 1 presentation a day now, even in this heat. I like to keep the continuity going. I'm going to show you that the fine structure constant, which is, it's a good way to remember the number if you would like to just have an idea of the size of the number without knowing what it applies to. All you'll know is the size, but it's 007. It's 0.007, and then it is irrational. But it's known to an extraordinary degree of precision, and it's always the same precision wherever it's measured. Although there would be a footnote to that as well. There usually are footnotes to statements anywhere in science. You have to read the footnotes if you want the whole story. But what I'll be showing you, which was pointed out to me by none other than Lori Gardy, who I consider to be one of the best out on the internet right now. Her style is a bit tedious, it's a bit slow, it's a bit stuttering. Quite frankly, it's a bit irritating. I'm here to tell you that you need to adapt to Lori Gardy, no matter what you think of her style. I did, and I am extremely thankful in an abstract way. Although I'm actually quite grateful. it was a challenge because she's not mellifluous and polished in her approach. But what she is absolutely meticulous as a scientist must be to do what she does. She does unit analysis. She has a special form of unit analysis which I admire extraordinarily without really even knowing much about what they do, except in the most obvious sense, which often is enough to know. She uses a system of modified unit analysis. She provided me one of the most critical insights that I needed into angular momentum. And so her series on the fine structure constant, I believe she doesn't even call it that. She's actually talking about something else that's related to it, because there is another number that's related to the fine structure constant. Now, when Feynman presents it and others, they'll talk about the reciprocal, which is about 137. It's 137.0 something. So it's close to 137, but of course, every single digit in these numbers is significant. But it is interesting that the reciprocal is usually cited, but the reciprocal of 137 is 007. Now, 007, this number, over 2 pi, which is tau, is the anomalous magnetic moment. And we're going to stop there. I hope that entices you. It certainly is enticing me. I don't know yet, but I'm going to broach this now. I may be able to explain the anomalous magnetic moment and thereby explain the fine structure constant, because they're related, directly related. That's not commonly brought up, but Lori Gardy proves it, and it is true. I believe that I'll be able to get at this through the fine structure constant, but my goal will be to correlate it physically, structurally, with the anomalous magnetic moment. These are two highly different things. Well, nature suggests otherwise. I believe that spherical geometry will provide the key that finally defines what is the fine structure constant and what is the anomalous magnetic moment, either of which, if it's actually explained to any new threshold, we're looking for anything now. Science is desperate. Desperate! I think I have the answer. This is Anagalactic, bringing you the secrets of the universe. Keep listening.